Hello, Honors Pre-Calc students. Today is just a following along for a quiz review. So I'm going to give you a little hint, and then you can pause the video, work out the problem, and then play to see how you did. So for your quiz, it's going to be 6 questions. Make sure that you have the identities on hand. Reciprocal quotient Pythagorean from 5.1, Trig Identities. And then also make sure you have the unit circle on hand for the trig equation stuff. I guess I wrote this out of order, but whatever. So 5.1 is trig identities, 5.3 is trig equations. Take a look at number 1. We want to find the tangent if we know that the secant is the square root of 7 and that sine's greater than 0. Whenever you're given information about if something's positive or negative, that's basically just information you're going to use at the end to see whether your answer is positive or negative. So when you're given only one piece of information, one trig function, what you can do is use a Pythagorean identity, or you can draw out a right triangle. So I'm going to actually do this in 2 different ways and show you how you can get the same answer both ways. And go ahead and pause, see how you do. All right, here are 2 different ways to solve this one, to find the tangent of theta. This is the way that's using the identities outlined in this section. This is a way I want to give a shout out to John Carreras, who used right triangles when doing all of these types of problems, and it really helped him, so I told him I'd put it in the video, and I found it to be helpful as well. So I'll explain that one in a second. This is the Pythagorean identity we're going to use. We're given info about secant and we want to find tangent, so we're going to use this one. I just plugged it in, squared root 7 and got 7 and solved for tangent. We got the tangent is the square root of 6. Now, how do we get that? How do we know if it's positive or negative? Well, tangent is sine divided by cosine, right? So we know that the sine's positive. We also know that the cosine is positive. Secant is the reciprocal of cosine, and if secant's positive, so is cosine. So sine's positive, cosine's positive, therefore the tangent is positive. This way is interesting. I did not have root 6 when I drew it out. So basically we're given the secant is root 7. Therefore I know that its reciprocal cosine is 1 over root 7. So I drew a right triangle as best I could. Here's the right angle. Put theta in there. And I knew cosine was adjacent over hypotenuse. Then I used the Pythagorean theorem to find the square root of 6. Now, look at how similar this is to what we just did here. It's the same thing. That's why these are called Pythagorean identities over here. To find tangent, tangent is TOA. So I took opposite divided by adjacent and got the square root of 6 in the same way. So there are a couple different ways to take a look at this. We can use those identities or the Pythagorean theorem, but they both stem from the Pythagorean theorem. Okay, the next type of problem is simplifying trig expressions, and your main goal is to get stuff into terms of sine and cosine if all else fails, and also to use those identities. So go ahead and write these down, pause, and see how you do. All right, take a look at number 2. Secant is 1 over cosine. 1 minus sine squared is just the rearrangement of sine squared plus cosine squared equals 1. So 1 minus sine squared is cosine squared. Then we can write it as a single fraction and cancel out a cosine top to bottom. So if you cancel out a cosine from cosine squared, you're left with just cosine. If you cancel out a cosine from cosine, you're left with 1. So our answer is cosine.
For number 3, we rewrite tangent theta as sine theta over cosine theta.
Sorry guys, had a frog in my throat. Then we can multiply by cosine, which you can rewrite as cosine of theta over 1. I didn't have to rewrite anything with this term since it's already in terms of sine or cosine. Then when we multiply our fractions, we can cross cancel, being left with 3 sine theta plus 2 sine theta, and we can combine our like terms to get 5 sine of theta.
Okay, moving on.
Okay, try this next one. This is rewriting without a fraction, so essentially simplifying. Go ahead and pause, see how you do. Okay, again, we're going to use our Pythagorean identity. This is equivalent to cosecant squared. Again, when all else fails, right, we still have a fraction. When all else fails, rewrite in terms of sine and cosine. The reciprocal of this, right, is cosine. So we can rewrite the numerator as 1 over cosine squared theta, similarly with the denominator. And then when we are dividing fractions, right, I feel like I say this every day, multiply by the reciprocal of what you're dividing by. So when we multiply straight across, we'll get sine squared over cosine squared, which is tangent squared. So we have successfully rewritten this without a fraction using those identities, right? The Pythagorean identity, the reciprocal identity, and getting everything into terms of sine and cosine. Okay, these last two problems of your review are from 5.3, the more recent stuff we did. And I'm just going to be asking you to solve on the interval 0 to 2 pi, both closed brackets. So if 0 is a solution, so would 2 pi, right? They're the same spot on the unit circle. So if we look at number 5, obviously we want to get sine by itself. So go ahead and pause, solve for x, see how many solutions you end up getting. Okay, we found our two solutions to be 7 pi over 6 and 11 pi over 6. This first part involves algebra. When we solve for sine of x, we get negative half. Where on the unit circle is the y value negative half, right? Where is the sine negative half? That is only in quadrants 3 and 4. So that would be 7 pi over 6 and 11 pi over 6. Okay, this next one is asking you to do the same thing. We do see a squared here, so just remember when you will eventually have to take a square root, you do have plus or minus in your answer. So you're going to potentially have more answers than just 2 for your final answer. Go ahead and pause and see how you do. All right, go ahead and check your work. Here we have 4 solutions because when we solved for the tangent of x, from here we had to take the square root of both sides. Again, we needed a plus or minus. So I took the square root of 1, square root of 3. If you want to just keep it written like this, that's fine because it's not really your final answer, right? It's not like you're giving this as an answer. But you can think of it like this too. So basically, where is our tangent plus or minus 1 over root 3 or plus or minus root 3 over 3? Well, since it's plus or minus, we have to take into account where is the tangent positive or where it's negative. So there's going to be 4 potential answers here. And tangent is this value in the pi over 6 family. So at these 4 spots, our tangent's either positive root 3 over 3 or negative root 3 over 3. Remember, to find tangent, we take the y value divided by the x value. So you can think of this as where is y 1/2 and where is x root 3 over 2, if that's more helpful to keep it this way. Okay, that's all I have really for your quiz review. Your next step is to download the quiz. It is attached as on Blackboard by the quiz assignment that I've put up. It's a PDF. You are to take this by yourself. Of course, I can't control if it's open note, open video, open book, whatever you need, just not open cadet. So you are not going to be working with anybody else. Please be honest. You can print the quiz if you want, or if you don't feel like doing that or can't print it, no worries. Just answer it on your own sheet of paper and upload it just like we've been doing with other stuff. Now, I have been taking late work, but I'm not going to for any assessments. So be sure that you have this in by Friday at noon. That is the deadline. Otherwise, there will be a late penalty. I also need you to show your work in order to earn credit. So remember those 2 things and you will be successful. Good luck.